So what we're going to do today might seem like we're going a little bit off track, but I promise it's not. Well, that's neat. It's already going to go out on me. Let's see if it keeps doing it. Guess not. All right. So when we do sections 9, 8, and 9, 9, which this isn't either one of those, sometimes your answers aren't going to match the ones in the back of the book if you check your answers. We're going to take it a little bit further and kind of learn one of those skills that if you understand it now, I think in the future when you take Algebra 2 and some things like that, you'll be thankful that you were introduced to this. Okay, and it's simplifying radicals. Radicals are a type of number that involve roots. So like the square root of 5, right, is a radical. The square root of 2, the cube root of 10, whatever. Some sort of root. And I actually had a professor, instead of calling it the square root of 2, he called it radical 2. Right? There's just those kind of numbers. So they can actually be simplified. And I don't mean plug it into a calculator, see what the decimal is, and round. That's rounding, not simplifying. So you'll see what I'm talking about here. So let's first quickly review what perfect squares are, because we're going to need to know what our perfect squares are. So I have up here, 1 times 1 equals 1. So 1 is a perfect square because of that number. Okay. 2 times 2 is 4, so 4 is a perfect square. 9 times 9 is 81, so 81 is a perfect square. In other words, if you take a number and square it, the result is a perfect square. So 14 times 14 is 196. So 196 is a perfect square. So I kind of have a row of your first few perfect squares, but it doesn't have an ending. Right? It goes on towards positive infinity forever. All right, so you got 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc. All right, so we need to know what perfect squares are. And we also need to understand this property. It says that the square root of A times the square root of B is equal to the square root of AB. So if you multiply 2 square roots, it's equal to the square root of their product. And the converse of that is also true, and the reverse order of it. So you can start with a number, A times B, and then split it up into 2 square roots. Okay? We're actually going to take advantage of this idea when we go to simplify square roots. And you'll see what I'm talking about. I'll draw it out in a longer process, probably more than you'll end up writing down, but at least you'll get to see it. And I have it kind of showing you here, the square root of 3 times the square root of 5, well, that's 3.8729, blah, 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 blah. 3 times 5 is 15. A times B is 15. The square root of 15 is the exact same number. So you can see an example where it's true. A times B equals this. AB, the square root of it, equals that. Okay. So let's look and see how we can actually simplify these. I'm going to start out with the square root of 8. Okay, what you're going to want to do is think back to your perfect squares, and you want to know, does this number have any factors that are perfect squares? Right, so 8 is not a perfect square. 1 is a perfect square, but that doesn't really help us. 2 goes into 8, but 2 is not a perfect square. 4 goes into 8, that's a perfect square. So I'm going to break this down to the square root of 4 times 2, kind of like AB, and then that would be equal to the square root of 4 times the square root of 2, and then what is the square root of 4? It's 2. So this equals 2 square roots of 2. Okay, so if we were to take a calculator and plug in the square root of 8, it would be equal to 2 times the square root of 2. You would get the same decimal. You can pause the video, grab a calculator, or just go to a Google's calculator and you can play around with that. Yeah, so the square root of 8 and 2 squares of 2 are equal to the same thing. So this is considered the simplified radical of this. It's not a whole lot different than taking a fraction, say like 10/25, and reducing it down to 2/5. Okay, these are the same number, but this is the simplified version of that number. Right? So it's kind of the same idea. We're taking a number and we're simplifying it. And again, I promise this will come back to what we're doing when we're talking about our quadratics. It's just a skill I want you to pick up in order to do the next kind of problems we're going to do. All right, let's look at another example. We've got the square root of 45. So again, 1 doesn't help us, and it's a perfect square, but so 3 goes into 45, it's not a perfect square. It goes in 15 times, 15 isn't a perfect square. 5 goes into 45, it's not a perfect square. But 5 goes in 9 times, and 9 is a perfect square. So we can break that down to the square root of 9 times 5, which would be equal to the square root of 9 times the square root of 5. Okay, this is that property I showed at the beginning. The square root of AB equals the square root of A times the square root of B. And then, of course, the square root of 9 is 3, so we get 3 square roots of 5. All right, 3 square roots of 5, I know that sounds kind of probably weird to your ears, but that's how you say it. 3, how many square roots of 5 do we have? 3 of them, 3 square roots of 5. It just means 3 times the square root of 5. Just like 3x means 3 times x. Same sort of idea behind the notation. Again, if you were to take a calculator and find the square root of 45, you're going to get some decimal, 6 point whatever. If you take 3 times the square root of 5, you'll get that exact same decimal. This number and this number are the same number. This is just a simplified version of that radical. Okay, square root of 32. Now, some of you will see this right away, and some of you won't. Some of you will see that 16 goes into 32. Okay, let's play pretend that we didn't catch that. All right, so let's say instead of catching that 16 went into 32, which is the best and easiest way to do it, but I just want to show you something so you get to see what happens here. Let's say instead of catching 16, we catch that 4 goes into it. So we say that, well, that's equal to 4 times 8, which is equal to the square root of 4 times the square root of 8, which is 2 square roots of 8. Okay. It is true that this and this are equal, but what you want to do every single time is look at your number you have left, the radical that you have left, and ask yourself, does it also have any perfect squares that go into it? And it does. Right? It was the one we did back in example 1. It's the square root of 8. So you can say then that that equals 2 times the square root of 4 times the square root of 2. That 2 came from right here. And then I broke 8 into 4 times 2. And that's going to equal 2 times 2 times the square root of 2, which is 4 square roots of 2. Okay. Again, you could have caught 16 at the very beginning, and if you catch that, do it that way. I just wanted to play pretend that we didn't catch it so you could see how to keep going if you found out there was another perfect square inside of there. And what is the square root of 14? Or I'm sorry, what is the square root of 16? It's 4. So, and you're left with 2. All right, this one's kind of bigger. We have the square root of 16 here. So, if you get one like this, you just have to grab a calculator and start trying different perfect squares. Okay, now, I would immediately try 4 because it's even. And according to my calculator, I don't know if you can see that. Don't even know really where you're looking. It ends up being 4 times 54. So the square root of 216 equals 4 times 54. So we have all that inside of the square root. And then break that into 4 times the square root of 54. And that's 2 square roots of 54. 54, right, we don't really have to use the calculator there, at least I hope not. You should know your times tables. 9 goes into 54 6 times. So now that's going to be equal to 2 times the square root of 9 times the square root of 6, which is equal to 2 times 3 times the square root of 6, which is equal to 6 square roots of 6. I'm going to see if that's right. It doesn't feel right, but let's see if it is. Maybe I made a mistake. Square root of 216 is 14.696938. And then 6 times the square root, no, that's not the wrong button, times the square root of 6. Try that again here. 6 times 14.696938. Yeah, so that is right. Thought I made a mistake, but I didn't. Now, the fact that our final answer had 6 on the outside means that 36, which is a bigger perfect square, we could have caught that in the very beginning, and we would have been able to factor it out as well. All right. You'll have 16 of these in a homework assignment. I don't think it will take you very long. Heck, I didn't even really look at the homework assignment very closely. It was an old worksheet. I may have done 1 or 2 of them there for you. So, but anyway, the Google Doc is called Simplifying Radicals Worksheet. It'll be due on Tuesday. Snap a picture and get it to me on Google Classroom or by email. If you have any questions, I'll be available in office hours. See you guys later.